In today's lesson, we are going to look at Statistics Part 2, where we're looking more at displaying data and sampling techniques. So, to start us off, some of the key points: histograms. Again, histograms are essentially like bar graphs, but there's no spaces included between the bars. And histograms are used to represent continuous data. We'll say numerical because it's dealing with numbers, but specifically continuous. And we'll look at an example of something like that a little bit later. And the frequency distribution tables are essentially tables that we use to kind of tally how many values fall within certain intervals. Basically, it's a tool to help us create histograms, which again we'll look at an example of later. Population, and sample are two key terms that we use when we are dealing with collecting data. So population is every individual. So population is talking about every individual or everyone in a certain area that we're talking about or what we're concerned about when we're dealing with our data. And our sample is a group of individuals. A group of individuals or items or whatever it happens to be taken from a population. And the sample is the people that you're actually asking. So you're not going to be able to interview or collect data on everyone in the population. It's just not realistic in terms of time or resources. So you take a sample, which is a smaller group of individuals from that population. And how you take that sample depends on what sampling technique you use. And there's different pros and cons of each sampling technique. Again, remember in our notes you should have a table or a chart that shows all the different sampling techniques and some of the pros and cons for it. So a random sample or a simple random sample just means all selections are equally likely. So this basically means every individual has an equal chance of being chosen. So something similar to putting everyone's name in a hat and drawing 3 names. Stratified is where the population is divided into groups, and then a random sample is taken from each group. And the thing about this one is that the random sample is proportional to its size or to the size of the group. So for example, if you're dividing, say, the high school up into grades, that's fine. But if there's more, say, grade 10 students, you're going to take, or you're going to random sample more grade 10s overall, because there's more of them in the population. So you're keeping it in proportion in that sense. A cluster sample, the population is divided into groups, and then a random number of groups are chosen. So similar to stratified sampling, however, in cluster sampling, after you divide them into groups, you're selecting the entire group. So if I'm dividing it up by grade, I'm going to select an entire grade. not just individuals from every grade or every group. Convenience sample is where the selection from the population is taken based on availability. Like for example, say now, if I wanted to take a survey about, say, COVID or anything that's going on, or I asked you to do that, you would go and ask your family members or people in your household because they are easily available to you. So that's convenience. And finally, voluntary sample. People volunteer to take part in the study. So this may be something like the surveys on YouTube that you see before you watch a video. It's voluntary. You don't have to do it. You're not asked to do it. It could be something similar as, say, voting on a talent show that you see on TV. Right? They put the number out there. Anyone's allowed to vote or to participate, but people have to volunteer that. There's no one forcing you to do it. Types of data. If we're looking at types of data, we have a couple different types. Categorical just means data that are types. Rather than numbers. So say like your favorite snack or your favorite sports, your favorite color, something like that. Discrete. Discrete is data that is distinct, or basically what it means, it can be counted. So if I wanted to know how many siblings you have, how many pets you have, how many students like a certain food, that would be discrete data. Continuous is, we talked about before with histograms, but continuous means data that can have any numerical value. So usually this deals with anything with measurements. So like heights, weight, time, things like that. Because if you look at height, basically height could be any numerical value. It's not going to be specific to, say, 1 meter or 2 meters, something like that. Types of graphs, again, we talked about. Bar graph, pie graphs, again, I'll just draw kind of small examples of them. Line graph, pie graph, again, we've looked at examples of how to calculate that. And histogram, again, we will look at a specific example of that as well. So looking onto some of the practice work, below is a couple of multiple choice questions. So if you have your own page, again, I suggest that you pause the video to try these on your own because they are just multiple choice questions, and then we'll come back and look at the full solutions. So coming back to the multiple choice, in the first example, a school is divided into 4 groups by grade. 10% of each grade are randomly asked how much time they spend doing homework. This would be an example of stratified sampling because you're breaking it up by grade and you're taking a certain, or the sample that you're asking is proportional to the grade. Because it's 10% of each grade, if you have a higher number of grade 12s, you're going to be asking more grade 12s. It is continuous data because we're dealing with time, so there is an infinite amount, or it could be basically any numerical amount, right? It could be an hour, it could be an hour and a half, an hour and 45 minutes, or so on. So you could argue that it's continuous. Number 2, in Dancing with the Stars, at home, viewers are asked to call in to vote for their favorite dancer. So this is an example of voluntary sampling because they're not forcing you to submit an answer. And it is categorical because what data you're collecting is a type, or basically a category. So you're looking at individuals. So how many people vote for dancer number 1 and so on. You're not collecting any number values. Number 3, a class is divided up by the color of their shirt. All students with blue shirts are surveyed as to what their favorite movie is. This would be an example of cluster sampling because, again, you're breaking it up into groups based on their shirt color, and you're selecting all the members or individuals of a certain group. The data is categorical because, again, you're talking about a favorite movie, so that is a type rather than a number. For number 4, people working out at a local gym are asked how many exercises they complete during an average workout. This is convenience because, again, if you're looking for data based on workouts, it's easy to ask or ask people at the gym that are working out. And the type of data is discrete because, again, we're collecting numbers, but our numbers are limited to what can be counted. So you can do 1, 2, 3, 4, or 5 workouts. You're not doing anything other than that. You're not doing 1.5 workouts or 0.75 of a workout. Number 5, every 5th customer at a Tim Hortons is asked how many milliliters of coffee they drink a day. So this could be, based on the answers that were given, you could argue that it's a random sample because every individual has an equally likely chance of being that 5th person. But if you go to our actual sampling techniques chart, you could find a better example or better technique, which would be systematic. And although we didn't talk about systematic sampling is where you're taking every nth member of a population. So for example, as we see here, every 5th customer, that would be an example of systematic. And again, the type of data would be continuous because we are dealing with numbers when we're talking about milliliters, and it is a measurement. So there are quite a different or an infinite range of values that we could have when we're dealing with the milliliters. So moving on away from the types of sampling and the types of data, we're going to look at creating a histogram. So if we wanted to create a histogram, there's a couple things we need to do. We need to first figure out our range and then figure out our intervals. So again, remember, when we're dealing with histograms, we're looking at intervals as our bars or categories. So in order to do that, we need to figure out our range first. So we figure out our range, we want to find our highest and our lowest data point. So in this case, we see 14, and our highest, if we scan through, we see 89. We continue to go through, is there anything higher? There is not. So our range, we are going to do 89 minus 14. And we get a range of 75. And what we're going to do is our histogram should have between 5 and 20 bars. So what we need to do is we need to take this 75, divide it by 5, and 75 divided by 20. And we want to see what we get. So we get 15 and 3.75. So we need to find a value in between 15 and 30 in 3.75 that will be our interval range. So I would say a nice number would be 10. Right? 10's easy to count by when we're going up. So 10 is going to be our interval length. So what that means now is that our intervals are going to be a range of 10. Because our lowest number is 14, that means our lowest interval should start at 10 and then go to 20. Again, remember in our notes we talked about the square brackets and the round brackets. The square brackets means it includes the number. The round bracket means it does not include the number. So our first interval goes from 10 to 20. Our second one goes from 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, and 80 to 90. I'm going to stop it there because our highest data point is 89, so we don't need to have an interval that's higher than 90 because none of the data is going to be in any of those intervals. What we're going to do now is go through and create a tally based on the numbers, or how many numbers fall between 10 and 20. Again, remember, if it's rounded, we do not include it. So if I find a value of 20, I'm not going to include it in this one. And the reason for that is it just prevents us from counting a number twice. So I'm going to go through and find numbers between 10 and 20. So there's 1. There's only one value. So the tally is 1. Frequency is also 1. Now we're going to look for the next one, anything between 20 and 30. So if we go through, there's nothing between 20 and 30, so that's fine. So our frequency is 0. Next is 30 to 40. So there's 1, 2, 3. So there's 3 values. 40 to 50, we got 1, 2, 3. I'm not going to include this 50 because, again, the rounded bracket means I don't include it, so it will be counted later. 4, 5, so there's only 5 numbers here. 50 to 60, so 1, 2, 3, 4, 5, 6, 60 to 70, 1, 2, 3, 4, 5, 6. Oh, no, just 5, 6, 7, 8. These two 70s I'm not going to include, they'll be in the next one. 70 to 80. Going through. 1, 2, 3, 4. And 80 to 90 should be all the last numbers, so we got 1 and 2. So one way we can check just to make sure we have the right number of numbers, you could add up your frequency, which should add up to how many data points you have. Once we have the frequency, what we're going to do is we are going to graph this. So if we go to our graph, our frequency is going to be on the y-axis or the left side. And because we are looking at test scores, our test scores are going to be along the bottom. And we are going to go from 10 to 90. So just put, say, 10, 20, 30, 40, 50, 60, 70, 80, 90. So we go back up. Let me actually just zoom out a bit. So 10 to 20, we had a frequency of 1. So I'm going to draw a bar up, going up to 1. Be filled in. From 20 to 30, it was 0. So I'm just going to draw a line across the bottom to show that there is something there, but it's at 0. 30 to 40 is 3. Again, create a bar there, spanning 30 to 40. 40 to 50 is 5. So again, the thing about histograms is that the bars are touching. Because the data is continuous, we're showing that they all touch. So the bars are representing every value between 40 and 50, not just a specific category. 50 to 60 is 6. 60 to 70 is 8. 70 to 80 is 4. And then 80 to 90 is 2. So there we have our histogram. If you really want, you can put the values above it just to help reference. When you go back, but there's your histogram for the test scores. So again, this lesson focused mostly on sampling techniques and displaying data. Again, if you need more specific information or other examples, please go back and look at the lessons or the previous lessons on these concepts.